really, I only have the iPad here because if the squirrel comes by, I can show you. He's so cute. He eats those cookies I leave out for him. Okay. All right. So today's plan. Now, this is week 4, isn't it? Yes, it's week 4, and we're quite deep in this course, and we're going to talk about arrays today. And by the end of today, you should be able to use all of the skills you've learned so far. I think these are basic skills. Yeah. Okay. Because what we do when we learn anything is just take the basic skills, and the basic skills should just become second nature to us. And then you can start building the advanced skills on top of that. And the advanced skills are actually algorithms, right? So right now, you're really not learning the logic of computer science. So technically, I could say that you're not learning computer science at this point. You're just learning the syntax of C++, just how to use a language. And I think by the end of today, you should be reasonably conversant with this new language you're learning. How cool is that, right? So some of you already know programming, but those of you who don't know programming or didn't know programming when you started, by the end of today, or this section, arrays. And by the way, if you're looking at Michael's modules, Michael Losov's modules that I've linked into Canvas, arrays is not discussed in week 4, you will notice. Yes, I mean, because Michael's had a different plan, a contour that he followed through the courses, and I think for him arrays came later. But I like to cover the arrays earlier because arrays are still not part of object-oriented programming in a sense, right? So we're talking about NATO arrays, and then after the midterm, we'll talk about object-oriented programming. Is it classes and objects and things like that? How you can manipulate these things to do what you want them to do. And so when we start talking about objects, it's good to have all of the basic skills tucked away in the back of our heads, and that's why I want to move the arrays, which really aren't that deeply, intertwined with objects, to the first part of this class. So until about the midterm, we are essentially not programming in C++, but C. Yeah, because C, in theory, or it doesn't have objects, right? It only has structures. And so we're just using C until then. We're not even using structures or objects, by the way, right? So plain programming in C, like, vanilla, non-object oriented programming language. Yeah.
Actually, that is pretty wrong. I mean, cout's an object. Like, we're using cout, we're using std string.
Yeah. Okay, but what I'm saying,
C++.
Thank you for that observation. But what I'm saying is that you don't need to know any of that. Right? So using the objects is not really programming, object-oriented programming, right? So just like, people would say, oh, I know machine learning, I can do AI. And all they're doing is just using SageMaker and things like that that are out there that other people have done, right? So that's really not object-oriented programming. So by using cout and all these objects that other people have created, you're just being a faithful user of things that other people have done for you. We haven't displayed the skills needed or the knowledge needed to go in and implement the objects ourselves. That is what object-oriented programming is, not how to use an object, right? So just because I know how to use an iPad doesn't make me the creator of an iPad or know how to make an iPad, yes? So that's where we're going with this. So until about the midterm, we're just doing plain, procedural programming. Yeah. And then after the midterm, we'll start talking about objects. And that's when the pace will start picking up. Right? And when the pace picks up, you will actually feel it. You'll feel it, and I want you to feel it in a good way, not in a bad way, because you're sitting in a car or a Tesla in ludicrous mode, and you're not belted up or something like that, and someone hits the gas. So you could feel the acceleration if you're prepared for it in a good way, or you could feel it in a bad way. Okay, so we are going to accelerate in 2 weeks. So there's enough notice for us, 2 weeks time, to get up to speed before then, because otherwise it will be much harder.
Yeah, I was just pointing out that objects aren't the only thing that makes C++ not C.
Yes, of course. Well, I'm talking about the principles here, the concepts and the principles, not just the superficial aspects of it. So, all right. So what we're going to talk about today is is arrays. And I've sent out a bunch of sample problems for you to implement and showcase in class today. And we'll do it just like last class. And so I'll make a list. I'll get names from users and so on. Yeah. And if you're interested, well, by the way, obviously I need to talk about arrays and introduce arrays before you can start implementing arrays, because, some of you have already taken a stab at it and implemented these array-based programs, but, a large number of you are not yet familiar with arrays. Yeah, and you need to know what arrays are. So I'll give you a really brief primer about arrays. I promise to keep it really brief this time. And then, and then people will start coming to demonstrate their code. And while they're demonstrating the code, you can look at it. And after you've seen a couple of demos, you're probably in the mood to start tinkering with code yourself. And you're going to create some code of your own that you can demo to the other students before the end of class today, right? So even after we've started demonstrating, you can send me email or say in the chat window that, hey, Anand, I'd also like to go now. Yeah? All right, great. So let's talk about arrays briefly. And to recap, what have we covered so far? We've covered, data representation, basic control structures like branching and looping, expressions, how to calculate things. This is the bread and butter of computer science, yeah? So we've covered that. And then what else? Looping, yeah, we've covered branching and looping, right? So you have a bunch of fundamental structures in your arsenal, as it were. And so this is the last bit that will go in before you can start playing around and making more, significant pieces of code. All right, so let's say we have a whole bunch of, let me see what's the best way to, yeah, okay. Let's say that I have a whole bunch of variables. Okay, so far you've written programs that have one variable or two variables, maybe 10, even 10 variables. Yeah, but very soon you'll write programs which use many variables. And when I say many variables, I don't mean 10 variables. I don't mean 100 variables. I'm talking about, can someone give me an idea of how many variables you will pretty soon start using in your programs? Take a wild guess, right? By the end of today, maybe. By the end of today, how many variables do you think your programs might be manipulating? Just type in the chat window or hit the space bar and speak out. But take a guess.
Arrays in this? Are you allowing arrays as variables in this?
But think about how many variables, meaning locations in memory, whose contents you're going to change. Right, a location in memory whose contents you can change is a variable, yes. And of course, well, you could have a big location in memory and you change it. It doesn't count as many variables. It counts as one. So I want to say individually addressable locations in memory. Yeah. So that may be a more precise definition of what I'm asking, right? So okay, Trevor says 30. Augie says potentially hundreds of thousands. Saul 10, Bale 100. How come it's the same people every time? All right, I want some new people to also chime in. Okay, who else is here? Oh my gosh, we've got a lot of students today, and but nobody else is chiming in. Okay, potentially millions, Giorgio. All right, thank you. All right, so you are going to be using millions, billions. Yes, okay. Is that Lanso or Ianso? I mean,
Ian, so I can see from here it's an.
Oh, Ian So, is it? That's your first name and last name?
Ian, yeah.
Okay, Ian, okay. Yeah, billions, huge amounts, huge numbers of variables. In fact, you can have as many variables as your computer's memory allows. So if you have like terabytes of memory in your computer, you can have trillions of variables, quadrillions of variables. So that many of variables you can have, and arrays make that all possible. And so what is the advantage of using arrays? Why can't we just say, I have these variables that are basically suffixed with these numbers. Like I can have x underscore 1, x underscore 2, x underscore 3, and so on up to x underscore a billion. Yeah. So I could have that many variables in my program.
Type out those numbers one by one by one by one and declare them one by one by one by one.
Okay. So it's tedious and painstaking, and it's probably not even practical. Yes. Okay. So that would be one reason. That would be one reason to have all the arrays, all these variables in an array. But an array is really a collection, right? So instead of saying that I have these billion variables, I'm going to put them all in a sack or a bag, and they're all in there. Now, the disadvantage of doing that is that I've got all the variables in a sack, but if I want to access a particular variable, how do I do that? So I have to go into the bag and start looking for that variable. Yes. So arrays give you a singularly, a saliently powerful feature that makes them ideal for computing. Yeah? And what is this property that arrays have, and how does it work? Okay, so can someone take a stab at this? Tell me, what is a property that we get from arrays using just the knowledge that you have accumulated so far in this course, not from past studying or past research you've done, just using knowledge that you have accumulated so far in this course, right? Or obtained so far in this course. What is the categorize them to be more easily accessible? How, right? How does it categorize them to make the variables more easily accessible to the code? Suppose I want to access the memory location of the 3,400,000 x, right? So x underscore 3,000,000,004.
Each variable has a unique index.
Right. Okay. So how do I access the variable if I know the index? I mean, so let's say my array is stored at memory location, let's say X. Okay, my memory location X, and my arrays elements are A1, A2, A3, and so on, right? A1, A2, A3, A4, all the way up to A billion, A trillion, right? Yeah.
Right next to each other in the stack.
All right. So I would say bar name of index, but that's just the same as saying I want A of a billion, right? So you're saying I want A of a billion. Now, so here is the challenge, right? So I'm going to share my iPad screen now. Good, I have an opportunity to use an iPad. All right, let's see. I have to share the screen, not the. I've got a whiteboard now. So I have this memory location. Can you all see this blue line, so blue rectangle that I drew?
Yes.
Okay, so I have in this blue location, I have, I'm going to put all these, numbers, A1, A2, and so on, okay? A1, A billion, okay? 1 billion, and so on. So all of these variables are in here. And that's a collection. That's a collection, an array. Now, I want to access as one of these elements, right? One of these elements. Let's say I want to access that. All I have, though, is where the array is stored in memory, right? Because if I have, I'm actually explicitly storing the location of every one of those variables, it's not feasible. Yes, if I have like 1 trillion variables, I can't have 1 trillion different pointers, right? I can't have 1 trillion different locations also stored in my program, because every location is itself a memory, is itself a variable, isn't it? So I have a variable called X in memory, and then I have the location of that variable, right? The memory address of that variable also stored in another variable, so that I know that if I go to this variable, I can find the location to access that variable, right? So this is my room number. Let's say on campus, this is my room number, okay? 4-1. Damn, I forgot my room number. It's been so long since I went to campus. I don't know. I forgot my room number. Okay, let's say my room number is 4129. That's my old room number, okay? 4129. Yeah, that's my old room number. And that, let's say, is room number 0, okay? Room number 0, and then there's room number 10K, right? Let's say this is the entire Foothill, and it's 10K employees, and everybody has a room number sequentially, right? So, but it's a long corridor. It's a long corridor. And everybody is, everybody gets the same sized room, right? That's very important. Yeah, it's the same size room. So And is everybody with me? Let me pull up my chat window because there's 3 chats that I haven't read so far. Okay. All right. Let's not talk about Turing complete and so on. Why don't we, if you are interested, Daniel, let's start a discussion in the forums. First of all, describing what you think is Turing complete, right? So you can't just ask in the forums, hey guys, do you think this is Turing complete? Yeah, because first of all, you got to demonstrate that you understand truly at the core what Turing complete is and what a Turing machine is and so on and so forth, the details of that. So once in the forums, you ask a question, first demonstrating your knowledge, okay? And say that I'm open to correction if there's any mistakes, but I'm really curious about that. I want to know. Then you will find that people will jump in and say, hey, you can take a look at this, take a look at that, okay? So that would be a good way of asking that. Okay, all right. So, yeah. Don't talk about other stuff in the chat, guys, here, okay? So imitation game and things like that, you keep that for your personal discussions on Slack or elsewhere, okay? So here, we only get to talk about computer science and my stories, okay? These are my stories because I'm taking the pain to describe computer science to you, so I get the luxury of sharing my personal stories with you from time to time.
Just because you said the Turing machine, that's why.
Yeah, let's not talk about Turing machines now, okay? So, well, I understand maybe it looks like a Turing paper tape, right? Your Turing machine, paper tape, and so you thought about that, but let's not talk about that now. All right, so what is the unique advantage we get from using arrays that lets us get away? Arrays lets us get away with storing just one address, right? I'm not going to store, in my program, I'm not going to store 1 billion addresses. I'm only going to store one location. This is the room, this is the address of room number 1 at Foothill College, all right? That's the only thing I know. Well, I know one other thing, okay? I also know the width of each room, right? My room is 15 feet wide, okay? Every room is exactly 15 feet wide. Yeah, so every room, so this distance here, that distance, right? This distance, that's 15 feet. Is it a 2 or 1 for a feet? I don't know, right? I'm a metric systems guy in my heart, I guess, because in India we use the metric system, right? So two marks. I think is that inches or feet? All right, so that is 15. I'd be a squirrel if I had a room that was 15 inches, right? So 15 feet. Okay, so this is 15 feet. I know that. Okay, and I know the address of room number 1. Okay, I know the address there. I know each room is 15 feet wide, and I need to go to room number 1 billion. Okay, what is a good way to do that? One way is to basically go to here. Okay, to here. And then I know I need to go to room number 15 billion. So I need to know, Augie said something. You need to know the address of the first location, add to its index, first location. Yeah, thank you, Augie, okay? Thank you. So Augie just wrote something in the chat window, which really is what I'm going to explain now. All I need to do is use the arithmetic knowledge we have so far got in C++, which essentially says, I know the address of the first element, I know how big each element is, and I know how many elements I need to get past. Therefore, I know that the element that I want is at 0 plus 15 times 1 billion. Okay, so the element I know is 15 billion feet from here. Oh, geez, I'm drawing on my iPad and on my Mac screen with the pen. I should be drawing here. Okay, so so I know that I need to go 15 billion feet, right? This is 15 billion feet. I think it's one apostrophe for feet, right? Or for feet, not 2. 2 is inches, I think. Okay, so 15 billion feet. I need to go this way. Now that is only possible because we knew 2 very important facts. We know that all the elements in the array are placed one after another with no gaps between them, right? So one after another, sequentially, no gaps, they're just right there. And the other is that we know that every single element in the array is the exact same size. If one of those properties is untrue, the array doesn't work. Is that 100% clear? Yeah, we're cool with that so far.
Yes.
Okay, now that makes us, that gives us even more flexibility, because even mathematically you can think that I don't have to go here and then march 15 billion steps here. I can basically even calculate the if I'm here, I can calculate the hypotenuse, right? And go directly to that place. And that's exactly what happens in an array. So you just go directly to the element you want. And the beauty is that you can do that in time. Yes, Augie, right? It is in time that is not only faster than looking through each element, because if I had to look through each element, right? So if I had to do this, if I want to get to there, I need to go here and then I need to walk 15 billion, right? Even though I know where I need to go, the time I need to get to the element, right? This element is proportional to how far away it is from the beginning. Yeah. If the room that I'm after is far down the corridor, it's going to take longer for me to get there. And so the time taken is proportional to how far down the array your element is. So that would be what I would call a linear search, right? It's a linear, meaning it's like a line. You need to go. So linear, one after, and it takes time. But the beauty of an array is that it gives us constant time access, right? It's not even faster, it would be constant time, because the constancy comes from the amount of time taken to calculate where you need to go. And that's constant, because once you know where you need to go in memory, accessing the memory is pretty much constant time, right? So you can tell the compiler, get me the location, get me the contents of location 1 billion. Get me the contents of location 0, location 2. All of those take about the same amount of time in the hardware. So no matter how big your array is, you can always access individual elements in the array in constant time. So that is something that is very, very, very important to keep in mind. Okay, it's like super duper important to keep in mind, because that is something you will exploit like 1 billion times. Even when you're working on really complex algorithms with graphs and other data structures, this is a concept that you will exploit again and again. So it's very important to keep in mind. Just tuck away in the back of your head. Arrays give you constant time access to every element in the array. No matter how far down the list of elements your element is, constant time. Whether it's the first element or the trillionth element, constant time, okay? And that is the most incredible power of an array. I get an echo. Oh, maybe my iPad needs to be. Okay, maybe that's better. Yeah. Hello, hello. I still hear it. I still hear a faint echo from my iPad. I don't know where that's coming from. Okay, all right. Is everybody clear so far?
Yes.
Great. All right. So now we have two options. Now, what time is it? That's all. That's all my introduction for today is going to be. What time is it now? I got 8:28. Yeah, cool. We finished everything in, well, this discussion in less than half an hour, which is fantastic. Now, what we can do now is I have a choice for you. Now, I don't know if anybody has gotten to quest number 6. Has anybody gotten to quest number 6?
No, I had a problem on quest number 4 involving floating point.
Yeah, okay. All right. So is chat window, has anybody got to quest number 6? Hit the spacebar and say yes. You don't, yeah, all right.
I'm still on quest 4.
No, yeah, okay. Sumit says yes. Okay, so there's one person at least who's gone to quest number 6. And in quest number 6, you have an interesting puzzle or a problem to solve. And so you should be looking forward to getting to quest number 6, because in quest number 6, you are going to start creating names out of thin air. Okay, so if someone in your family or extended family, right, has a new baby and they say, hey, I want to name this baby, can you come up with a name? You don't have to look at ancient texts and say, hey, here's a legendary name and so on. You call them Camelot or Arthur, right? Or Rama or Krishna. You can actually say, hey, I got an algorithm that will come up with a really cool name for your kid. Okay, so here, run this program and it'll give you a name. Actually, you know what? One of my past CS2A students did that in JavaScript. and I hosted, and I said, yeah, it's really cool, man. I will host your project if you give me the source code. I'll put it up on my on a server. And I actually did that. Let me see if I can find it right now. You can play around with it sometime. Give me 1 sec, okay? 2 minutes. Yeah. I need to open up a. Let me say. Oh yeah, Zoom is maximized. Oh, is Zoom maximized? How do I go? Yeah, okay. Now let me go to. Let's try Safari, and so I'm going to share my Safari. Oh, I should share my Safari screen with you guys. All right, share screen. Yeah, okay. Stop the other screen. Where's my Safari? Safari, okay. All right, can you guys see the Safari screen? Can you see it?
Yep. Yes.
I think.
Yeah.
I've forgotten where it is. I think it's called Namer. What a funny name. Oh, okay, yeah. All right. Namer sounds like a really odd name. Maybe I'll change it. Maybe I shouldn't change it because some people might actually. Yeah, okay. So so he wrote this. This is a CS2A student from, I think, 2017 or 2015, maybe 2015. That was like 5 years ago, right? He wrote this 5 years ago, and I stuck it on my server. I hosted that time, and I completely forgot about that. And I think about it from maybe once a year, but it's really cool. So if you want a name that's let's say 7 letters long, you just say 7 and then hit enter. Right, okay, so it gives you a name, Ibi Juje or Ibi Huhe, all right, depending on how you pronounce the words. You can also hit I'm feeling lucky, and it'll just select a name of its own. Iggy Mom, yeah, right, I see so. All right, so the cool thing about these names are that these names are all pronounceable, right? And who knows, maybe they're even, real words in some language, yeah? So, so in your Pro Quest, and so this was so cool. So his idea was so cool that I incorporated that idea into quest number 6. So when you do quest number 6, you're going to have to do that, except in C++, not in JavaScript, okay? So you're going to have to do that in C++, come up with the names. But today, what I can do is, well, you can take that to the next level. Instead of coming up with names, let's come up with sentences, because I think in CS2C, is it? Maybe CS2C. No, in CS2B. In CS2B, what we did was we basically took Kavi's idea and turned that into a sentence generator. So it would just generate nonsense sentences, but grammatically right nonsense sentences. How cool is that? Okay, so I can do that right now. It'll probably take me 10 minutes, just like last time when we wrote that program on screen. I'll just do that. If you're interested, right? So, and that will be an exercise in arrays too. So it'll give you some ideas about of how to use arrays in your own little programs that you're going to demo. Yeah, so I will use arrays and create this little program with your help. We'll all create it together. In fact, we're all going to create it together, and then that may be your first program, and you can take that and modify that further. All right, if anybody's interested, I can do that right now. Yeah, we'll database at different kinds of words. Now you'll see how that happens, right? So we are going to start filling in the bins for the different kinds of words, okay? So in fact, when we start designing the program, we're going to do this as a community, right? All of us together, we're going to do it right from the beginning. If you're game, tell me, and I will start an editor window right now, and we can start going. Say yes or no.
Yeah. Okay, that sounds all right.
Sure, okay, all right, great. So, well, there's only one person who wants to see this. That's all?
I think it's 2. I saw someone in the chat as well.
Oh, okay, yeah, all right, thank you. All right, lots of people, great. So I'm gonna open up a terminal window here, and, all right, so that's my terminal window. I gotta share my terminal screen. Where's my terminal? There you go. All right, can you all see my terminal screen? Yeah?
Yes.
Okay.
Yes.
All right. Now, as I'm going to type my code here, so I'm going to type my code here. When I ask a question, or when we're collaborating and you're chiming in and saying, "Hey, fix that. There's an error," and so on, do what Andy or someone else did last time. Just basically just hit the space bar and say, right, "Hey, on line 21, you got a problem. Can you fix that?" And so on and so forth. Don't type in the chat window, because I can't. It's hard for me to look at the chat and then look at the code and back and forth, even though they're side by side. You know, once I get into this, I'm not looking at anything else. And even though, you know, there might be something right next to it, I can't even look at it because I'm just looking at this. Okay. So, so you have to help me out here. All right. Let's say, what we call it. Give me a good name for this program that is going to generate sentences. Generate sentences. I'm going to call it a really boring name until you guys come up with a cool name. Okay. Make sentences, or makesent.cpp. Okay, so hash include IO stream, and right now, let's say we're not going to accept user input. Okay, so I don't need SS stream to and so on and so forth. I'm just going to using, and then the other include files we'll insert as and when we need. Okay. Oh, okay, and oh, I forget. You know, is there a semicolon after this or not?
Yes.
Yeah.
Thank you. All right.
Anon, Anon,
Yeah.
is this a Vim editor or just terminal?
I just edit it. I think no, it's just Emacs.
Emacs.
Okay. All right. So now I'd like someone to tell me an English sentence, any English sentence that has, you know, a suitable richness of parts of speech. Like, for example, you could say it needs to have an adjective, or an adverb, and, you know, maybe not all parts of speech. Let's say something like the happy cat sat on the blue mat, right? Or something like that. So tell me a sentence that has a couple of adjectives in there, and maybe you can throw in an adverb too, right? You can say the happy cat, you know, smilingly sat on the blue mat, right? So you can add an adverb if you want, but certainly have an adjective or articles in there. So give me one sentence, just one sentence, okay? Not many sentences. So what we're doing here is we're designing this program from scratch, okay? Meaning that we're going to start and build up not only the program, but also the design of the program. So the program, even the program design does not exist at this point, remember, okay? So we're designing, so the flow and the logic and the structures, everything is being designed right now. Even what we're going to do with this whole thing, right? So give me one sentence and that's going to be our seed, okay? We start from that seed, okay? So someone give me one sentence and I'm going to put that sentence in comments here, okay? At the top, give me one sentence. Anyone? Alexis, how about you give me a sentence? I. Oh, no, all right. Okay, I. I is a noun, yeah? I. You want to start with a noun? Yeah, okay, I
briskly walked down the spacious hill.
Sorry, say that again. Is this a hiss or something?
I briskly walked down the spacious hill.
Spacious?
Spacious is a weird adjective, maybe a different one.
No, it's fine. No, it doesn't matter. Spacious what?
Hill.
Oh, hill. Okay, great. Thank you. Thank you very much, Alexis. Okay, so now what we want to do is we want to say, let's just tag these, okay? So I have, I'm going to call, I briskly walked down, yeah? So I'm going to say, I'm going to say it's a noun, okay? Adverb, okay, adverb. And what is walked?
Verb.
Verb. Okay. I'm going to say, you know, walked down is one word. So let's just keep it simple. Okay. Walked down. Verb phrase. I'm going to call it a verb phrase. Okay. Walked down. Just to keep this simple. I don't want to. Okay. I don't want to, you know, qualify it like that. Walk down. Okay. There's a verb phrase. Okay. Verb phrase. And then I have an article. I'm going to say an article walk down, article. Okay. Article, spacious hill, adjective, noun. Yeah? Is that a template? This is a template, okay?
Should we call the last noun a object instead? So we don't
Yeah,
want.
no, I would rather have it be a noun for reasons that will become clear very soon. Yeah?
Okay.
Because, a noun is an object, yes, but it's more general than an object. Because a noun can also be a subject. All right. Now, here is what we're going to do. How many different parts of speech do we have in that sentence?
5.
5. Okay. So I'm going to do string nouns equals, okay? Now here, I'm going to give it a bunch of different nouns, not just I, okay? So I'm going to say I, let's say Alexis, let's say Daniel, let's say the cat, okay? That's also a noun phrase. So honestly, in fact, we should say this is a noun phrase, right? Let's say noun phrase. Yeah? Okay, the cat. Give me a couple more and then we can go on to the next part of speech. What? Oh, Anne. And owl. Okay.
Do you want to include the, because on the previous lines you framed the as an article instead of a noun?
Yeah, but I want to use. We'll see how this goes, and then we'll come back to this. Thank you. Was that Momo or Andy? Andrew. Andrew, thank you. All right. Yeah, thank you. Keep that in mind. We'll come back to that. Okay. So, all right. Let's say that's all we have for nouns. Let's say we need some adverbs. Ooh, sorry. This is how you declare arrays. Okay. Okay. You have the square brackets, and then that says what comes after that is an array. All right. Now, give me some adverbs. So Alexis said briskly. And then
Willingly.
Willingly. Okay. Oh.
Quickly.
Well, they're all, briskly and quickly. Okay, quickly. All right. And
Slowly.
Begrudgingly.
Sorry?
Begrudgingly.
I didn't hear that.
Begrudgingly.
Begrudgingly? Like this?
Yeah, that's an it. Yeah.
All right. I hope you didn't say that begrudgingly. I hope you said that happily or hippily.
Slowly.
All right. Well, we're getting to the end of the line there. We'll say that's it there. We'll come back and you can add to it. You can knock yourself out later. Okay. String verb phrase equals. Give me some verb phrases, right? So what did Alexa say? Walked down. So you could say, sang is a verb phrase. Sang, and then skipped. Danced. Okay, dancing is what we do all the time. All right. So what else? We're not calculus.
Coded.
Slept.
Coded. Yes, coded. Thank you. Let's say 4. Okay. You'll be surprised how many different sentences we can get just with this. Okay. So coded. Semicolon. All right, string, what else? Article, article is easy, right? Okay. Let's say the, and, let's make them all lowercase. And Amy. What else?
A.
Okay, that's a bit risky. It's a bit risky to put A in there, but I'm going to put it there anyway because in the grammar that I have in mind, the word that is following A could start with either a vowel or a consonant. Yeah, because you're not selecting the next word depending on what the previous word was. So I chose A for my previous word. I have to choose something that begins with a consonant. I can't say I have a artichoke, right? You have to say an artichoke.
So then by that nature, N and A have the same riskiness.
Yeah. Oh, yes, you are absolutely right. Thank you so much. So let's get rid of both. Well, let's leave them in there and see how many weird or off-sounding sentences we get. Okay, so let's just say we have 4 articles there, or let's say no, right? No and every, no and every.
Put a number as well, like 1.
Yeah, okay, 1. Okay, and all, 1 and all. All right. Okay. All right. Let's do. We've done articles. We want some adjectives. Equals. The quick brown fox. Right. Quick. What else? Quick. Quick. Smiling. Angry.
Optimistic.
Sorry.
Optimistic.
Again, I spoke. Say again.
Optimistic.
Optimistic. Thank you.
Delicious.
That's enough. Okay. Delicious. That was fantastic. Got the spelling right? D-E-L-I-C-I-O-U-S. Yeah. Okay. All right. So we've got adjectives, and then, that's it. We have articles, adjectives, noun phrases. That's all, right? So those are all we need to form our sentences. Yeah. Now, all we need to do here is we're going to pick a noun phrase, a random noun phrase, a random adverb, a random verb phrase, exactly in the same order, following the template that Alexis came up with. Yes, Alexis, are you happy with that? We're going to use your template. And then basically, essentially, if you think about it, what we're going to do is take your sentence and then substitute all of the words without changing the structure, the overall structure of your sentence. You're going to take your sentence and substitute the words, and so, and that's how it works, right? In art, in general, you take a song, a famous song, and then you change all the words in the song, but following the same meter, you get a different song, right? Yeah, I don't know. In the West, I think that many songs and the tunes are copyrighted, so other people are really scared to go in and pick up someone else's song and change it unless it's 20 years and it's past copyright. But back in India, when someone comes up with a song, lots of people will immediately generate many songs with the words changed, because each one of those is not a satire or things like that. Each one is an independent song in its own right. They all follow. They have the same tune, but they have different words and they have different emotive content, right? Because the words are different, the feelings they stir in our minds are also different, right? It's the same as with dance, the same positions, but different move sequences to go from one to another. So that's what we're going to do. Is if everybody is okay with this so far, what we need to have grasped at this point is this is how you declare an array, right? This is how you declare an array. You can after you've got the array, you can individually assign items to that, right? So I can say nouns of 2 equals, instead of Alexis, I could say, Saul or something like that. No, this is not Daniel. Instead of Daniel, it's 0, 1, 2. Alex. So yeah, all of the array indices start from 0, right? So I is 0, Alexis is 1, Daniel is 2, right? The indices always start from 0. The reason for that is because you can take the index, multiply by the size of the item, and add to the first address, and you get the address of the item that you're interested in. That's why, it's the index starts at 0. So if I want the location where briskly is stored, if the index of briskly is 0, the size of each string, let's say it's 24 bytes, okay? Or 20 bytes for each string. So it's 24 times 0 plus the place where the array adverbs is stored in memory. So that's essentially the first location, right? If I want to know where willingly is stored, okay, I would go to the place where briskly is stored and add the index of willingly, that is 1 times 24. So 0 plus 24. So byte number 24 is where I would be likely to find, not likely, certain to find willingly. Yeah, so that's how we index in there. And likewise, we can assign to these array elements also using that syntax that you see on the screen right now, right? Now, when you're using arrays, it's like super duper 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 important, okay? It's like super duper important. And 99.999% of all the bugs you will encounter in your code so far, it's not so far, even when you go on a 2B and 2C. And tell me if I'm wrong, okay? Well, I don't know, 99 is an exaggeration, but a huge number of bugs they're caused by accessing locations in the array that don't belong to you. So for example, if I take the array nouns, how many addresses do I have? How many items do I have in the nouns array? 1, 2, 3, 4, 5. Yeah, five. Yes. You hit the space bar and say
Yes.
yes. Yeah. Okay.
Yes.
Yeah. My chat window disappeared. Okay. So you got to hit the space bar and say yes. Right. So I have 5. So if I say I'm going to go and change the location of the 6th item, all right, the 6th item, what is the 6th item? What is the index of the 6th item?
It doesn't exist.
No, what is the
Doesn't
index
exist.
of the 6th item if it existed?
5.
5. Yeah. 0, 1, 2, 3, 4, 5. So the index of the 5th item is 5. The 6th item is 5. The index of the nth item is n minus 1. This is something that will have to become like second nature to you. It has to be part of your inner core, because as you're coding, you can't afford to be thinking about, oh, am I off by 1 and so on, right? Yeah, you can think about it, and you will have to think about it. But you have to think about it so often and get bitten by it and trip on it so many times, and that it will just become, automatic. So I can't do 0. So that's the 6th item, right? I can't do that because that location doesn't belong to me. The last location in the array that belongs to me is an owl, and beyond that, I don't have anything. Yeah? So actually, I don't want the cat and the owl, because what happens if I place an article in front of it, right? Then I'll have the cat or an the cat or something like that. Okay, so let's just keep it all very simple. Yeah. All right. So this is how you address locations, and this is how you assign stuff inside an existing array. Is everybody clear with that?
I have a question.
Yeah. Who is this?
Georgia.
Giorgio. Yes.
So let's say you want to change the value of an element.
Mhm.
If you do like the one you did on the last line, nouns, and you put the element number. Let's say we're going to change owl. So we'll put nouns and number 4, because it's.
Yes.
And then we put equal, and then we change the noun. Does it
Yeah.
change? Does it change the element also? Like,
Yes,
does it?
absolutely. It totally changes the element. And in fact, we'll try it. We'll leave it like that, right? Well, let's say that in this code where an element is an owl, we went in and changed it to Sal. Yeah. Okay. So that the 4th element is actually Sal here. So we're now when you run the program, you'll see that we changed it. Is that okay? Is that a good experiment?
Yeah.
Okay, all right. Now all I want to do here is to pick random numbers. Now this is in other languages, in JavaScript, Python, many other languages, even in Java, I think. When you use an array, a native array, you can ask the compiler or the runtime system how big the array is, right? And it'll tell you. Right? If I want to use nouns, I can say in JavaScript, I can say nouns.length. And this is automatically stored in the system, right? I don't have to define it. Every time I add something to nouns, that length will grow. Every time I take something away, the length will shorten. So that value is available in other languages, but not in C++ or in C, okay? But in C, you can get it if you use a class that is built on top of arrays. But we're not using vectors yet, right? Vectors are just like arrays, except it has all these other nice features like length and so on. So we're using native arrays all the way close to the hardware. We're talking bits and bytes here. Yeah, we're close to the machine. So that doesn't give you these fancy features, bells and whistles that come on top of the native array. So we don't have length. How do you calculate the length? How many nouns do we have? So what we're going to do is this trick, right? So this is an idiom. It's an idiom that you can keep in mind. So here's my comment, right? Select a random noun. Yeah. So how do I select a random noun? So I'm going to say int number of nouns equals, okay? I want to know the total number of nouns. How do I find the total number of nouns? Either I could go in and count here. Okay, 1, 2, 3, 4, 5. I got 5 nouns. Well, that's easy because I only have 5. But what if I had an array which had like 1 billion elements in there? How do I find the element?
Right.
How do I find out
Right.
how many elements there are in the array?
Length
Length of array.
length of array.
You can't do. How do you find the length of an array? Who said that? Who said that?
It was Georgia.
Giorgio, how do you find the length of the array?
You just wrote something right
Yeah, that's
before.
only available in JavaScript and the other advanced languages.
Oh, okay.
So how do you find the length of the array here? Take a stab at it.
So
You probably have there will be some I'm assuming there will be some character that will let you know it is the last element of an array.
Right. So you're
And if
talking
you
about
know
a
what the
sentence.
last element of an array is, if you know what it's indexed at, then you can subtract, do the arithmetic, subtract whatever it's indexed at, and that can give you the length of the array from the last element to the first element.
So that depends on knowing where the last element is located and the size of each element. Yeah.
If you
Correct.
get array, you add a nil byte.
Right.
Or a
So
null
we're
byte.
getting to the solution, right? This is really cool. These are the situations I really love about class, right? As I say, when there's an open problem and we're all taking stabs at it, right? Trying to solve this and that, and we're getting closer and closer. That's what is enticing. Yes. Anytime, anything we do, if we're just futzing around here and not getting any closer to the solution, it's not fun at all. Now we're getting closer to the solution. What Giorgio just said is not the solution, but it's actually closer to the solution. And that's what is really fun, right? So I enjoy that because we're starting out here and we're getting closer and closer, right? So, all right, tell me. Now, Giorgio said we can find, the length of the array if we knew where the last location was and we knew the size. Yes? Okay, now cue off what he just said. Right? Take what he just said and develop that a bit more. Come on, someone else, not Giorgio, okay? Someone else, take what Giorgio said. He said, if I want to know what the size of the array is, I need to just know what the last element's location is and the first element's location, and I know the size of the array, right? So I can, or size of each element, now arithmetically calculate how many elements there are. It's a fantastic solution, right? That is a fantastic solution, but unfortunately, I don't know where the last element is. Let's say, right? I don't know where the last element is. How do I know? So,
why don't we do what with C strings and define a sentinel value?
No, I don't want to use. I don't want to use sentinels or C strings. Yeah, I don't want to use sentinels. We will talk about sentinels later.
When your array is, when you allocate a certain section of memory to an array, if you didn't have some sort of terminating character or some sort of end point, then you would have to allocate indefinitely. So when you define your array, don't you have to have some sort of endpoint? And if you have that endpoint, then you can take the endpoint and the starting point and do the difference.
Right. Yes, absolutely. You do have an endpoint. When you tell the compiler, I need an array to store 5,000 integers, it will give you 20,000 bytes. Bam, like that in memory. Yeah. So the runtime system will give you your first, your start point is 0 bytes and your end point is 20 bytes. So you have that in memory. So you have the start point and the end point. But
okay, so as long as you have the start point and end point, then.
But the thing is, I don't know what the end point is. How do I know what the end point is?
Could you just do a while loop and just set it so that the parameters is against the null terminator?
But I don't know if my array is terminated with a null. I'm not using a sentinel, right? Who said that?
This is Brendan.
Brendan, yes, thank you. That's a very good guess. It's a very good guess. And that is exactly how you find the length of a string in C, for example, right? So if you use a sentinel delimited data structures, right, then you can bank on that and say, I'm going to keep going until I hit the sentinel. But even if I did that, that is, I would say, a less preferable way to find the length of the array, right? Because every time someone asks you the length of the array, if you're going to start, walking the array until you hit the sentinel, and say, okay, I walked this many miles, and so that's your array length. That's a very, not very, but it's a less efficient way of finding the length of the array, yes? Now, I think there is a reason why nobody has come up with the answer so far, and it is because there is a certain feature of C++ that I haven't introduced, yeah, so far.
I'm guessing there's an operator.
So what is that operator? Yeah, take a guess. What is that operator?
It's like an operator that gives you the length, of the array.
Right.
Because
Thank you. Who is that? Is that Daniel?
It's Georgia.
Giorgio, yes, thank you. Wow, you're for me over Zoom, your voice sounds very similar to Daniel's. So yes, so there is an operator that will tell you how big your array is, except it is not a runtime operator, right? It's a compile time operator, meaning the compiler will fill this in for you. You don't have to wait until your program runs. So the compiler itself will fill it in for you, and it is called the size off, right? Size off. Now, size off is an operator. I don't know, you should look it up, whether it's an operator or a compiler directive. But certainly it gets filled in by the compiler before it's compiled, right? Before the compiler turns your code into machine code, the compiler will make sure that size of nouns returns the length of the array nouns, however, not the length in the number of elements, okay? Because the compiler at that point doesn't know. Well, actually, strictly speaking, it knows how many elements there are. No, it knows how big each element is, so it could in theory.
Well, then if we use this value and then divide it by the,
yes, right?
then
So
it's fine.
thank you. Who was that?
It's Giorgio again.
Giorgio, yes, thank you, Giorgio. That's exactly what we do, right? So we're going to take that size off will always give you the size in bytes, in individual bytes, not UTF bytes, right? Individual bytes, 8-bit bytes. So size of nouns tells me how many bytes the array spans in memory, okay? Bytes. So equals size of nouns, okay? Divided by what's inside of nouns? What is the type of each element?
It's a string.
Yeah, okay.
Character
So
array.
size of noun. Oh, no, let's say string. I'm not, well, we're going to try this, and I'm, my memory. I'm not sure if that is going to be correct, but we'll try it and find out. The reason I say that is because in here, I actually don't have strings, if you notice, right? I have what are called just constant C++ pointers, constant character pointers, because each one of those is basically a character string. So in a character array. So I don't want to go into the nuances of that, but we're going to try this and see if it works, because if there were integers, no problem, right? And I say, integers, but in this case, I'm going to assume that these character arrays there, Alexis, Daniel, Cat, and so on, the strings, they get converted into strings by the compiler, which has an array of strings and is given the constructor of the compiler is given an array of character pointers, right? This is an array of character pointers. Inside of curly braces, you have an array of character pointers, addresses, memory addresses. And on the right, it says here's an array of strings. Take these character pointers and put them in the array of strings. They're different, right? So I'm hoping and I'm guessing that the designers of the compiler said, well, these are character pointers. I need to put them in string bins. So, but fortunately, every character pointer, I know how to convert character pointers into strings. So without the programmer having to worry about that, I'm going to convert these character pointers into strings and put them into these arrays, okay? So that's what we're hoping will happen, okay? So I'm going to do this for all of them, okay? So number of nouns, and what else do we have? One more, right? And then what, adverbs? Okay. Oh, I got to do that for the other ones too. The inside of the adjectives. Is that it? Articles. Okay. Now I want to change these guys here. This would be adverbs, and this, and then we need to change the string things too. Okay. Verb phrases. Articles, and adjectives. Oh, they're all strings. That's fine. They're all strings. So the denominator could just be size of string. Yeah? Okay, so now we have the number of each of these guys. Now I want to select a random. All right. Now I want to select I'm going to say srand. Okay, all right. So I'm going to select a random noun. How do I select a random noun? So I'm going to say string noun equals nouns indexed by, yeah? Is everybody, this is one line, but you have to stay absolutely in step with me and make sure you understand this, okay? Index
Yes, and then we
of,
put the integer value of it. Yep.
I'm sorry?
Yeah. I said that we put the integer value of it, the one that we wrote, number underscore nouns.
So you
You
mean,
already, yeah.
yeah, but is that enough? We can't do that, right? Because that's not going to give me
No,
a
we
random
have to close the brackets and then.
No.
-1.
Sorry, who was that?
Andrew, -1.
No, if I do -1, it'll always give me the last noun. I want a random noun.
You need a random noun you need the random noun from num nouns. You need the random operator to kind of like work on num nouns, right?
No, I want an index. I want a random number that spans between 0 and 5. Is it 5? My random number should be 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. My random number should be one of those 4, right? In fact, number of nouns is going to be 5, right? So I want a random number between
You can
0.
either put a random number operator on num nouns, or you can subtract a random number from num nouns.
Right. What? So yeah, this is cool. Go on. Give me a better way. Okay. A better way meaning it's more idiomatic. You will be using this repeatedly in your life. You'll see this, very frequently in other people's code. So it's an idiom, right? So give me a good idiom that I can use there. All of everything that many people said, they might work, in a kind of roundabout way. But there is what I would say, a standard way, a standard recipe, right? Where people will just do this, not even thinking, just do this and get on with the next thing in that list, right? So what can I do? I want a random number between 0 and the number of nouns.
What if you use rand and then modulus?
Thank you. All right, who was that?
Mod.
Was it Daniel?
Daniel.
Momo. All right.
Yeah.
Well, I think my voice, speaker identification is seriously off kilter today, right? So I'm mistaking your voice for other people's too. All right. So what Momo said was we're going to do rand.
It was Daniel.
It was Daniel?
Yeah, it was me.
All right. Thank you.
Yeah, that's why I said. Must have
Right.
heard that.
All right. So, but Momo said something. Momo also said something, right?
Yeah, but I don't think it wasn't like helpful.
All right. No, that's fine. But it doesn't matter if you're helpful or not. Okay. In this class, I don't place any importance on whether you know the answer or not. I don't care, because knowing the answer to me in my books is worthless, right? But knowing how to get to the answer is worth everything. So if you understand the concept and the foundation, you have my kudos, right? But knowing this is how you do it, or saying, that, yeah, it's good because it will help you achieve other more sophisticated things, but always the concept. So it's okay, which means that it's okay. It's okay to pipe up and be wrong. That's the important thing, right? So that's what I like. I like it when people take risks, right? Step out and say, this is what, I'm going to try this. But be yourself,
Also.
Yeah. Don't be afraid. Don't be afraid. The fear is the only thing that holds people back, right, from achieving great things. So don't be fearful and take a guess, take a crack at it. After all, this is just a Zoom class, right? And yeah. Okay. So now I want to do the same thing with. So does it work? First of all, does this work? Is everybody okay with this? Does this work?
Well, you need to include C time and CSTDlib.
What?
For the because rand or CSTDlib and you're seeding it with time.
Oh, I see. Wow. All right.
So
We'll compile it and see if and see the error, and then go back and do that. What else? As far as this line goes, my question is everybody on the same page as far as that very important line goes? This is the way in which you choose a random element from an array.
I guess one question I had was rand parentheses. Does that generate like a random number between like 0 and 100, for example? What is that exactly?
Right. So you can always, I think it's 9. Okay, so can you see the home page?
Yeah.
Can you see the terminal? Okay, that is a manual page for the rand function that I just used. Yeah, and you see that it returns a random integer. And by the way, it's not random, right? It's the word pseudo-random is like super duper important because it goes all the way to the heart of philosophy, right? Whether the universe is deterministic or acausal, because you can't generate a truly random number according to the deterministic theory of the universe, because there's nothing that's truly random. Everything is preordained, and if you know enough physics, you can predict everything. So you say it's pseudo-random. And pseudo-random means it looks like it's random, but it's really not random because there's so many factors going in that it is computationally infeasible today, given today's technology, to generate that random that number using deterministic methods that we currently know today.
You go into quantum physics.
Yeah. So even if you go to quantum physics, yeah, well, if you use quantum techniques and generate a random number, maybe there's a better argument there to call it a random number. But using deterministic techniques like we do now, we can't call it a random number. Okay, so the range, I believe, rand max is on this computer. I don't know what rand max is because what is rand max? Oh, you can find out, right? It's defined in std, but I think it's the maximum integer. But let's assume it's going to be between negative 32K and plus 32K. So let's assume it's a 2-byte number, okay? 2-byte. Rand returns a 2-byte number between minus 32 and plus 32. We're going to make that assumption. It doesn't matter to us, right? So that number, oh, no, not negative 32 to plus 32. What am I saying, right? It returns a number from 0 to 64K, right? It's unsigned. It returns an unsigned number from 0 to 32K. Is that what it said? Did it say unsigned? What is the signature? Oh, it actually returns int, not unsigned. But it does return. That's really strange, isn't it? Okay, so the manual page says that it always returns a positive, non-negative number, 0 to rand max, yes?
Yeah.
But yet the return value of this number, this function, is int, not unsigned. Now, if you were to design this function, you would say it returns an unsigned, right? Or size t. Size t is unsigned. So functions like this, right? You shouldn't look at them as bugs in the design of C++, but they are like black holes in astronomy. So right, or distant stellar objects in astronomy, because you see these distant objects and say, well, obviously that the light from there is redshifted so much, so it got to be so far. That's what we say, right? We don't say, oh, we got to find a new kind of star that emits light that is, completely defies physical expectations. No, we don't say that. It's far away. So when you see a function like that, rand, and it always returns a non-negative number, but the return type is int, not size t or unsigned, right? But then here you'd think like a master astronomer, master scientist, and say, well, the designers of C++ or C, this function is a C function, the father of C++, as it were. So those designers were intelligent people, right? Because they were programmers. All programmers are really intelligent people, right? So they're intelligent people, and they're returning something that's non-negative, but yet they chose int. What could be the reason for that? And then the only reason you could think of, because assuming that they are intelligent people, is that rand is not an early function. It's not a new star. It's a star that has come to us from ages ago, far away, when signed and unsigned, or size t didn't exist, or one of the very early functions, which was released with an int signature, and then people started using it, right? So many people started using it. Now, if you go in and change the signature, it's going to break so many programs out there. So because of the history of that function, it has retained that less than appropriate signature. So when we look at things like this, you can get the same amount of, a similar amount of pleasure as an astronomer would get when they see a distant galaxy and say, wow, okay, that galaxy doesn't behave like it should. And then my conclusion from that is because it is so far away, not because it is near and it's wrong. It's far away and it's still right. So so rand is still, it's so far away in history, but it is, is all right. So anyway, you see where I'm going with that. Okay, so it returns something in that range. So we got a random noun. Is everybody okay that we got a random noun? We need 5. Was it 5 or 6? Six of those. Okay. Adverb is going to be okay, so I'm just going to do this. Noun with, what's the next one we have? Verb phrase. Was that, did it get everything? Okay. And what do we want to do? Noun with article. And then noun with, what's the last one? Adjective, right? Okay, now we have at our disposal a randomly chosen noun, a randomly chosen adverb, and so on. Are we in a position where we can stitch together this brand new randomly generated sentence? Yeah? Yes or no? Hey guys, I'm not looking at the chat window, okay?
Yes. I'm sure now.
Okay, thank you. All right, so here comes the sentence from Alexis's template, okay? So see out noun, space, adverb. Is it adverb? Yeah. Space, verb phrase, underscore. Space. What else do we have? Article, adjective, noun again, right? They're all similar. Space, adjective. No, we don't want to use the same noun again. Maybe we should say noun 1, noun 2, you think? Yeah, I think we need another noun at the end. Yeah, so I'm going to generate noun 1, noun 2 here.
This is when subject and object could be useful.
Yeah, different ones.
In the top int main, the string is named verb phrases, but here it's verb phrase. Will that be a problem?
Yeah, one has an S, one does not have an S.
Yeah, string verb phrases at the top. Yeah, there.
So just on the lower section, the only one that needs to be changed is verb phrase into verb phrases. Yep, because the rest of it is all verb phrases.
And also the C out needs to be changed.
No, you're going too fast for me. Okay, string verb phrase equals verb phrases.
So change that first verb phrase to verb phrase with the S at the end.
Why? Because I want a single verb phrase.
Okay, I don't know how this works. So
No.
Doesn't
Let's make sure we're all on the same page. I want to select a random verb phrase. Yes.
We're just for the commonality of syntax, since everything else previously was labeled as verb phrases. No, I guess it doesn't matter. Yeah.
No. I need to understand that. Maybe you have something. Maybe, even if it's an aesthetic issue. Please.
No. You're at the end of the day, you're changing in that last section, the select a random noun section.
The last section. I'm sorry.
When you're addressing, you're qualifying multiple plurals, and then you're making them singular. But I think you're doing that on purpose.
Yeah, I wasn't sure if it was another variable or not. The string.
Right. This is my cursor. Can you see my cursor? Is this line?
Yes.
So tell me what I should have in this line.
So
equals?
The current pattern is you have string singular item equals the plural item. Done by random. So adverbs needs to be changed.
This should be adverbs. Yeah. Not verb phrase. I was looking in the wrong place. This is what you meant?
That's the That would be correct. Yes, I think whoever was asking the question originally, they were not sure if verb phrase and verb phrases should match or not. And I think you are purposely making it so that they do not match. You're purposely making it a plural into a singular because we obviously
Yeah,
have
I see that.
plural verb phrases, plural nouns, plural adverbs, but you want a singular output.
Yes, yes, yes. I want to select one. I'm giving it an array and I want to select one, and one is obviously a singular. So on the left-hand side of the equals, they should all be singular.
Okay, got it.
Got it? Okay, so we're ready to run this now. And chances are it won't compile because of that issue that Daniel brought up, or Daniel or Giorgio brought up before, saying that include file is missing. So we're going to give it a go and see what happens, okay? So let's say, what was the function, the program called? Make select students. No, not select students. Where's today's program? Oh, make sent. Okay, make sent. Nobody came up with a better name for this program. Okay, not CPP, right? So I want to make this program. Okay, so it does need that stdlib, like he said. So we're going to go here and go up to the top of the program and include cstdlib, right? Which is the header file that declares the srand function, probably even rand, and I don't know if time is needed to be. It's probably included from there. Okay, good. All right, so it's compiled, and now if we run this program, it's going to print a sentence using Alexis's template. I don't know what the sentence is going to look like. Maybe I hope it's grammatical. Okay, so let's run it. Okay, Daniel briskly skipped no optimistic eye. All right, wasn't really. Let's try one more. Daniel quickly danced the quick Alexis. All right, Saul begrudgingly danced. Oh my gosh, I got a spelling error. Begrudgingly danced an angry Saul. Okay, this is really cool, isn't it? Okay, begrudgingly. Where's my begrudgingly? All these begrudgingly words are.
Wait, our sentence is completely wrong. We forgot to include a period.
Sorry?
Not a period. There's no
Where?
punctuation on our sentence.
Oh, you mean at the very end?
Yes, we didn't punctuate our
Yeah.
sentence.
Okay, well, it's thank you for that. But we'll leave the period out for now. When we're dealing with data processing, especially in natural language processing, sometimes it's actually beneficial to not end sentences with a period, because the periods will have to be stripped out in the post-processing when you're calculating counts and things like that. So sometimes when you do NLP, you'll find that, you actually explicitly strip the periods out. But, it's a good point. Grammatically and cosmetically, it doesn't look all that right when I run it on screen. So here you go, right? So each time I run this, oh, how come I get the same thing every time? Oh, because, yeah. I get the same thing. If I run it 2 times very, very quickly, I'll get the same thing, because the srand, the seeding, will happen within the same second. And so it'll give me the same sentence. So if I say make sand 10 times here, okay. Oh. Kill, paste, semicolon, okay. Oh, it does, okay. All right, so I'm going to run it 5 times, and you'll see I get the exact same sentence 5 times, right? And that's because when we seed the srand here, it seeds it on the current time. The current time is a seconds. Seconds don't change. If I run it 5 times and the seconds don't change, every time it's going to give me the same set of random numbers. Okay, that's what's going on. So in order to get a different sentence, you just have to give it a break, right? Now, and say make sand, I got a sentence, and then give it a couple of seconds or 1 second, right? Each time you get a different one. Does that make sense? Obviously, I can also, put that in a loop. I can put this whole thing in a loop. And you see the Saul, yeah, we never saw the word Daniel. Did we see the word 4? We never saw owl. Did we see owl? We didn't see owl, right? So in fact, let's go ahead and generate for size t, I equals 0, I is less than, let's say 100, I plus plus, yeah? And I'm going to generate 100 sentences. And in fact, let's also prefix the sentences with I so that we know what.
I have a question.
Yeah, sure, go for it. Well, Giorgio, is that Giorgio?
I'm Chanyeong.
Daniel.
No, Chanyeong.
Oh, Chenyu. All right.
Yes. So what does nouns for in brackets mean? That's owl.
Yeah. So what this means is that I'm going to take this array called nouns, go to the fourth element in it. 1, 2, 3. Fourth element, right? Fifth element, right? Starting at 0. Starting at 0. 0, 1, 2, 3, 4. And then assign the word Saul to whatever is currently occupying that spot. So currently I have owl sitting in room number 4. That statement, that line says, chase out the owl and put Saul in there.
Basically, Saul replaces owl, right?
Yes, Saul replaces owl. What a nice rhyme. Okay, all right. Yeah, so is everybody clear? Now I put this in a loop. Now this is going to generate 100 sentences. Okay, so. Okay. Okay, so let's see if we get 100 sentences. There you go. Oh, how come I'm getting the exact same thing? Do I have the srand inside of the loop? I shouldn't have srand inside of the loop. Yeah, okay. So every time if I keep pulling the random thing back to the beginning, it'll do the same thing again, right? So srand should be before. I only do it once. Here's a thumb rule. Whenever you call srand, call it exactly once as soon as you begin main, right? After the declarations, after the declarations, right? The first thing you do should be call srand, and after that, don't call srand at all. Okay, so there you go. So I get a whole lot of different sentences. And obviously you can see that we just did a very, very quick hack job with, very simple parts of speech. You can knock yourself out when you have time later and create a bigger program with, more interesting variations. Is everybody okay with that?
You said earlier that srand, so the reason we had identical sentences is because we called it within the same second. So how come when we do a for loop, does srand become randomized even though it's executed on the same second?
Very good question. Because the srand is not invoked inside of the for loop. It is invoked once before the for loop starts. Every time srand is called, it's going to yank up the random. So here's how how does rand work? Like I said before, generating random numbers is not a joke, right? We think random is so easy. Generating random numbers is one of the hardest things to do in computer science, believe it or not, right? It is one of the hardest things to generate a good random number. How do you know if a random number is random or not? Suppose I gave you a number, like, let's say, 41459, all right? So I just gave you a number, 41459. Is it a random number?
Depends on it's only as random as someone else cannot use parameters.
No, but but that's subjective, right? It's subjective. So let's see if we can come up with an objective criterion for randomness. What would be an objective criterion for randomness? Not, here's something, someone looks at it and says it's random or feels random or looks random. No, that's all subjective. We want an objective criterion that says if it satisfies that criterion, it's a random number.
If it satisfies a certain difficulty in replicating it using predicted parameters.
Okay, well, that is not again, that is not a definition of true randomness. What you're describing is a test for randomness, yes?
Each element got to have the same percentage of being selected.
Yeah, but even then, that is not how do you generate the randomness? It's the same percentage, but what is that percentage? How do you get a random percent? So generating random numbers is not a joke. It is not easy. It is very, so, but how do you test? So you can't, well, obviously, it's not something to discuss today because it is a subject of research, right? In fact, a good chunk of my own PhD was to do with what is randomness, right? What constitutes randomness and what is not random and what is deterministic. So in fact, you can say that, the number that I gave you before, 4, 9, whatever that was, it's not random because it is entirely predictable if you knew that those were just the digits of some sequential digits of pi, right? So 3.1414596, right? So if predictable sequences. So if I gave you the first number, so the early researchers in computer science and information theory came up with a beautiful criterion for randomness. And that criterion says if a number can be compressed, it's not random. All right. So meaning that the number cannot be compressed anymore if it is truly random. If I told you like 5,000 digits of pi, they actually look like they're random, right? Because you can't tell. But if I told you there are the 5,000 digits of pi starting at location 7, then they're not random anymore because they're predictable. So random basically means they're not predictable. Predictable using any known means of humans, right? So if humans cannot predict what the next thing is going to be using their entire knowledge in the world, then that is random, right? But if using something that anyone knows in this world, I can predict that, that's not random. So that's a condition of, so because of that, generating random numbers is not a joke, and you should never go around and play with the randoms. I want a bigger random, so I'm going to add 2 randoms together and get a random. No, that's not a good way to do it, because when you add 2 random numbers together, you lose the randomness. Well, you don't lose the randomness, but the distribution is destroyed. So if I took, for example, so yeah, the histogram, right? So very long time, this is about 20 years ago. I wrote this program 20 years ago, and I've been using it repeatedly in multiple contexts. So I still use it from time to time, maybe once every year. So I've used it 20 times in the last 20 years. But I haven't deleted it. It's a histogram program. So let's generate a bunch of random numbers. I'll just use a one-liner begin for I equals 0, I less than 1,000, I plus plus, print rand. I hope this is the right syntax. It's a long time since I wrote something in awk. Okay, so it works. All right, so I'm getting these random numbers. I want to bin them, right? I want to bin them into 10 bins. So if I say, so the program that one of my old programs is histogram, let's just pipe it to histo and see what we get. Okay, all right, so it's binned those numbers into 10 equally sized bins. The first bin is from 0 to point, I think it's point 1 to point 2, point 2 to point 3, point 3 to point 4. So those are the bins that I have. And it's taken all the numbers and put them in there. And I'm going to put them in place stars. I'm going to scale. Okay, so you see that, each of those numbers, 95, 100, 109, right? Those are all represented like histograms. I basically drew the histogram horizontally. So that's how many of the numbers I have. I have 100 total numbers, and they're distributed. 10 of those in that bin, 10 of those in this bin. Yeah, is everybody on the same page? So if I generate 1,000 numbers like this, right? If I generate 1,000 numbers, you'll see that scale 100. Okay, so you'll see that this is uniform. This is a uniform distribution. You'll see that every range has an equal likelihood of getting a number in that range. Yeah, even 10,000 does not seem to show it. Let's say 100,000, or let's say 1,000,000 numbers, and right. Okay, so I'm generating 1,000,000 numbers. I'm putting them all in bins. And I'm going to count the frequencies of each bin. Right? You see, it's an approximately uniform distribution. Everything is equally likely. Now I'm going to play around, right? This is what people do, people who don't know machine learning going in to do machine learning, right? Or people who don't know the theory or the underlying concepts doing. So that's what people do. And they say, oh, I'm going to use randoms here and there. They don't know how randoms work. I say, I want a bigger random. I add 2 randoms together. Yeah, it'll work. Your program will work, but it will work in a mediocre way. It won't work in the best possible way because you've actually destroyed one of the most powerful things that RAND gave you. The RAND gives you a uniform distribution. It's very hard to get a uniform distribution, right? So if you generate random numbers out of thin air, they're not going to be uniformly distributed. In fact, they will be normally distributed. Anything you see in nature, everything you see out here today, if I drop a ball 100 times and I take, measure how many seconds it takes to hit the earth from the same height, you'll see that, it's not uniform. It's actually normally distributed over, that's a bell curve, right? So you'll see, right? Now, if you futz around, fool around with the numbers that the system gives, the random numbers the system, RAND gives you, RAND will just throw in the towel and say, okay, you're on your own from now on. I can't handle this. I gave you uniformly distributed numbers. If you're going to take them and screw with it and destroy the distribution, it's up to you. So I'm going to go ahead and destroy the distribution, right? Do what a noob will do and say print rand plus rand, right? So plus rand, okay? So I took 3 random numbers, added them together, and then let's see what kind of distribution I get. And and if I add 3 of those, yeah, okay. So I'll have, in fact, because I added 3, my scale should be 30. Okay, so I want to have the same number of stars, I think. So now I just added 3 random numbers, and now the distribution will look different. So you see the distribution is now different, right? So I have more numbers here in the middle than in the ends. So you can see that, the more you have, the more, yeah, right? So you can see the distribution take shape like that. And I can say the interval is, I think I have interval, was 0.1 before. Let's say the interval is 0.3. Okay. So the shape will be more pronounced, I think. There you go. Right? So it'll look more and more similar to a normal distribution. So in fact, but on the other hand, generating a number that is precisely normally distributed is also very hard. You have to use something like a Box-Muller transformation or something like that in mathematics. But using this way, you can generate a Gaussian distribution. This is a Gaussian, right? It is first popularized by Gauss, Friedrich Gauss. So it's called a Gaussian. It's a normal distribution. If you want a normal number, this is one of the easiest ways to generate a random number. Take 3, any distribution really, doesn't even have to be uniform. Any distribution, and the reason you get that is a property that we now fondly call the central limit theorem, right? It's a central limit theorem in statistics. It says the theorem means it's an observation. No matter what the underlying distribution is, you take a bunch of those and add them together, they'll all immediately fall into the normal distribution, right? So you can have a weirdly shaped distribution, any shaped distribution, but take lots of numbers and add them together, the result will always be normally distributed. This is cool, isn't it? Okay, anyway, so that's where we went from there. So there you go. So there are your numbers. That's how you generate random numbers, play with arrays. Now, this is a, well, we're at 9:37. Damn, I had, yeah. But fortunately, arrays are penciled in for this entire week, this Tuesday and Thursday. So now I've done my demo, right?
So real quick, so we went on that the tangent about how do we generate random numbers, but I'm still not certain. So you put srand outside of 4. How come when we did 100 sentences, it produced random numbers?
Oh yeah, thank you.
If originally you told us srand had some kind of correlation to the actual second.
Yes, yes.
Why we had the same sentence.
Right, that's Andrew, right?
Correct.
Yes. All right. Thank you, Andrew. Yes, that's what I was going to answer, and I got drawn into that tangent. So because generating random numbers is so hard, what the C++ designers did was said, you don't have to generate random numbers yourself. We, the inventors of C++ or C, will generate 1,000,000 random numbers for you, right? They've generated 1,000,000 random numbers. It is all those million random numbers are stored in your C++ library in a big table. You don't see it, but it's in there. Okay, in the library, there is a table in which you have a sequence of, I don't know, 1,000,000, maybe billion, I don't know how many there are. There is a sequence, and it's a predictable sequence. Every time you ask for a random number, this is the most important part. Every time you call rand, where's the rand gone? Let me call to rand.
Bottom section, select the random noun.
Yeah, every time you call rand, it's going to go to that table that's stored inside the library, okay? And in that table, there is a needle, a pointer that says, here is where your random number should come from. It's going to take that random number, give it to you, and move the needle to the next spot, just like, And the next time you ask for a new random number, it's going to take the next one, right? Because the needle is moved, give you that, okay? Every time you ask, it'll give you the random number, move the needle. Now, every time you do that, every time your program starts, the needle always starts in the same place at the beginning of the table. Every time the program starts, the needle will always, that is why when you say, print a random number and you write a program, it'll always print the same random number because the needle starts at the same place. What does srand do? SRAND says, give me a random number or a pseudo-random number, your time or something like that. Now, based on the time or based on the number you give me, I'm going to, apply so much power and give that needle a whack on its head, okay? So that, like the Wheel of Fortune game, right? So that needle is now, as soon as SRAND hits it, it's going to go bam like that. And then it'll settle at a random place, okay? And from that point onwards, every time you call RAND, it'll still give you exactly the same behavior, right? It'll give you that random number and move, that random move, but it's not starting at the same place. SRAND has tapped it and it's just settled in a new place. So that's the only behavior of SRAND. SRAND will take that needle inside the table and then, shove it some random place. Not,
So
again, some pseudo-random place.
SRAND kind of gives a pseudo-randomness to where that pointer starts.
Yes.
And then whenever you call RAND, it will just go to the next subsequent number in this giant random table.
Yeah, exactly. Exactly. That's exactly what happens. And in fact, that's a very subtle point. It's a very subtle point, and most students in 2A won't really appreciate that until maybe towards the end of the quarter. And I'm glad that you guys brought it up right now, and so you get it out of the way, and you understand what's going on. Is everybody clear on what's going on here? Because there's a few different subtle concepts we covered here. We looked at size off. We looked at RAND, how RAND behaves, what SRAND is, where to use SRAND, how to select from arrays, and then, and stitch together a sentence. Actually, at the end of the day, we have a complete program in less than one page. I don't know, how many lines is this? How many lines is this? 41 lines, okay. 40 lines. Excluding comments, it's less than 40 lines, right? So we have a small program that does something interesting, right? So far we weren't doing anything interesting, right? I mean, the limerick was interesting, I guess, but we never did the limerick in class, right? So it's something mildly interesting. Is it mildly interesting? Because we actually generated some new content, right? Novelty is always the interesting part in anything you do, novelty. And here we're generating something novel because these sentences, nobody has seen them. Even Alexis hasn't seen any of these sentences coming out, even though Alexis was the first person to give us a sentence from which we got the template. Even she didn't see all those sentences, right? Everything is a novel sentence, a brand new sentence. And when that happens, you are yourself now tuned in, right? You're not tuned out, you're tuned in because you want to say, hey, I want to see what comes out next because I can predict it. It's all random. And now your entire attention, your 100% attention is focused on this, and so that's why interestingness is really cool to computer programs. So is everybody okay with what we've done so far in this demo? Did you get useful information out of this demo that will help you in your own coding? Ultimately, at the end of the day, that's the question you have to ask yourself. We all have to ask ourselves, is that what I've learned just now, is it going to help me become a better coder? Okay. Now, if the answer to that question is no, what I just saw is just Anand showcasing some stuff to show us how cool the stuff that he knows is, right? That is a total waste. In that case, then I won't even do these Zoom classes. You can just learn on your own if that's the case, right? Because I'm not, the intent of these classes is not to show you what, what C++ can do or what I can do. That's not the intent. You should ask the question of yourself in your own mind, not even verbally, right? Did I learn something in this lecture that would help my own programs improve, right? And if you're there, that's cool, because that's how we do it. You pick up all these little things from here and there, maybe one concept today, maybe another concept tomorrow, put them all together, because each individual concept by itself, it gives you a little bit of pleasure. But when you string them all together, in a sequence, then you get this beautifully neat beaded necklace, as it were, and that looks nicer. And so hopefully you've got one such bead today to tuck away in your bead box and pull out in your time. So we maybe have time for one person to demo today, I think. But then all of Thursday, the entire Thursday, maybe, if you want, I can give you a 5 or 10 minute lecture in the beginning or towards the end, right? So push my lectures towards the end so that I have a fixed amount of time. I don't eat into your time. And then we can do, your code. Now that you know what needs to get done, you can take your time cut code. And on Thursday, hopefully, we will get through, I don't know, let's say, last time, how many students did we cover? 10 maybe? So I'm hoping on Thursday we can do 20 students, right? 20 of you guys. Tell your friends, tell your friends. And these are things that I will actually, if you do a really good demo here, even though you may not participate in the forums for a couple of weeks because of personal reasons, I remember, right, when it comes time to participation points, I remember, hey, Alexis or Giorgio or someone, they participated really nicely in that class. They really ought to get points for that. And these kinds of things will make up for your participation points. So you should just take it upon yourself to play around. Playing is what is fun to look at, right? Not working. I don't want to look at you, grinding away. But when you're comfortable with it, and then you say, I'm done. I know how to do it. I'm ready to dance your dance. Then I'll come. I'll sit in the first row and I'll watch it to the end of days to come. Yeah. All right. So is that okay? Does anybody want to showcase their program today? It has to be a 5-minute program, less than 20 lines. Okay. If you have a program that's less than 20 lines and you'd like to show it to the rest of the class, you should take over the screen. I'll stop sharing, and then we'll have time to go over your code today. Right? Who wants to go? It has to be a simple program, okay? Not something. Use arrays. You have to use arrays better, and it's cool if you use loops and other branching statements. That's fine. But tell me, all right? So give me a volunteer, someone who wants to go next.
I would do mine, but but mine's like 31 lines.
Yeah, yours will take slightly longer. Is there someone with a simpler program that would like to go now? Giorgio, you have a math class. Okay, I'm working on it. Okay, so I'm going to be here. I mean, I won't shut down the meeting until 9:55. So we have 8 minutes. So if anybody wants to do it, say, if you're cutting it right now and you'll be done in 2 minutes, or even in 5 minutes, and you say, oh, I'll take 3 minutes to show my program, that's fine. In fact, all of you should be doing that, right? So all of you write a baby program of your own, right? And the first person to finish a program can grab the screen. How about that? Okay, it's a game. It's a game amongst you guys. Now I've done my program. Now do your own program. The first person to complete your program will get to showcase your program in front of class.
Honestly, if no one wants to go, like I did actually also while you were doing this one, I wrote down on a version of the program and I did some things slightly differently.
So I'm sorry, you did what?
So while you're writing down, like the program demo, I also followed along and did one that's slightly different.
Yeah, that's fine. It doesn't have to be the same. Slightly different. If you think you can explain it in 5 minutes, you should do it, right? And also, I think some people in the forums wanted me to go over some other stuff like setting up an IDE maybe and things. I don't think they are important from the perspective of class because we have a lot of important material to cover that's slightly more important. However, I wouldn't be saying that if we didn't have experienced people in class already, right, who already know these things. So maybe someone like Andrew or Giorgio or Andy, Momo, anyone who's been piping up with these informative clips in class, just organize a session, maybe on Zoom or Slack or something, and get people who are interested to come along. And besides, if you can't do that, you can go to the STEM Center. There's people in the STEM Center 24/7, practically 24/7 until about midnight on Sunday. How much better can you get it, right? So there are tutors. We pay tutors to sit down and field your questions until midnight on Sunday. And our tutors will be more than happy, right, to get you up to speed with IDEs and all these other questions you may have that are, tangential. and they'll be able to help you. And if you miss the tutors and you're more comfortable with your classmates, always ask one of your classmates like Andy. I'm pretty sure, judging from the posts that they have made, Andrew and Andy, they would be like super duper happy if you guys say, hey, can you give me a rundown of how to use an IDE or setting up an environment.
Yeah, I'm happy to help out where I can. I know Andy is as well. I know Andy has a slightly busier schedule than myself. He is a little bit more familiar with setting up IDEs, but anyone that does need help on any of these setup questions or just kind of preliminary questions, if you feel like you're kind of behind or having a hard time keeping up, feel free to just post on the Reddit. We can arrange a time. I have a pretty open schedule, so I can help where I can. And if we're able to pull in Andy from his schedule, I think he'll be happy to help as well, time permitting. So just post on Reddit. That way other students that may have the same questions or concerns can also jump on, and everyone can organize a suitable time. But yeah, I think Andy and I are both happy to help when we can.
Fantastic. Thank you so much. Yeah, and I want to echo that, post on Reddit, because I think the last time I noticed that they were asking people to join, posting, oh, this session is going to begin now, and come on, and it was all on Slack, and lots of people didn't even see it. And I think Giorgio was the only person who said, yeah, I want to, yeah. So I think on Reddit, more people will see it. Or find someplace, or go to Canvas, right? Go to Canvas. I don't know, somewhere you think you'll get.
Up to now, we've only posted on Reddit and or during the chats of the actual lectures. We haven't posted anything on Slack.
I thought I saw something on Slack that said, "Hey guys, do you want to do it?" And then Giorgio replied saying, "I can do it."
It might have been a secondary reminder, but everything any study session that we've done thus far, we've posted the links on Reddit and or the chat windows of the lectures.
That's great. Okay, thank you so much for doing that. Okay, because you're making it a whole lot easier for lots of your classmates and also for me, because then we can start, talk about other interesting things in class. Yeah. So. Remember what Andrew just said, guys. There's a lot of help in class. There's so many people that.
And so anyone that saw Momo's chat, we're going to do a quick session after this lecture is over. But just like Giorgio kind of pointed out, he has math class. So again, anyone that has a time conflict that can't attend a study session but wants to, just yeah, either contact me or Andy or Momo, and we can find a time to make it work.
Thank you so much. Yeah, it's fantastic. I wish I could also participate. What time it's going to be now? But yeah, I got it. Maybe I'll stop by at some point if I have time. It's lovely what you guys are doing. I love being part in the middle of your circle. I love being in the middle of your circle and just looking, because anywhere I turn around, people are doing interesting stuff all around me. Right? What more could a teacher dream of? Right? So it's great. Thank you so much. All right. If you guys don't have any further questions, let's reconvene on Thursday morning at 8 a.m. And then be ready to demo some code. Okay. And if you want, you can do these rehearsals with Andy and Andrew and all these other people. You can do those rehearsals on Slack if you want, right? And then, but you don't have to, right? I think you shouldn't. In fact, if your program has bugs, don't fix them in elsewhere. Fix them online so that all of us can fix it together. Because what I notice amongst the beginners anyway is that they have bugs that they're really scared of to fix themselves, and because they think that other people didn't have these bugs. But if you come to the demo with a program that has a bug, they'll see that, oh, your program also doesn't work, and I have the same kind of error. Oh, that's how you fixed it. I can fix this too, right? So I think that's easier for many people. And so if your program has bugs and you think you're brave enough to showcase that program with a bug so that we can all fix it live. Bug fixing live is actually pretty cool, right? Because we're all I think that's, you'll find out when you start working with teams and many people are looking at the same code trying to fix the bug, you'll see what a tremendous sense of intellectual community, right? Because people always feel good in a community, right? Because everybody's thinking the same thing. And then when you're all huddled together from other cubicles. Everybody says, "Hey, look at Andy's bug. He's not able to fix it. This regular expression. What's wrong with it?" Right? And then immediately, like 7 or 8 programmers from all the other corners of your, floor will come and say, "I want to look at this," and they're all looking at, "Hey, I think that star is probably extra." This is, and that is actually a very fun feeling. It's almost like watching a play, right? A little, not an entire play, but one scene, one beautifully shot scene in a movie or something like that, right? So it's fun. So get situations like that into our class, right? Bring bugs in your code. Don't fix them, and then we can all fix them together. Guys, bugs are our food, right? We're birds. We're all these birds like jays and starlings. And what do they eat? These birds eat bugs, right? So we want bugs. Bring more bugs to our class, and then we can all eat those bugs and feel happy. Yeah. Okay. All right. So I'm like super excited. And we're already into week 4, which means we only have like 7 more weeks left, and we have to cover all of the material. But I'm confident we'll make it, right? I'm confident we'll make it. But you have to stick with it. You have to stick with it. Watch that video that I posted, okay? Especially at 9 minutes into the video, watch it. What does she say? She says, it takes perseverance or something like that. Right? If you stick at it, you'll find not that you can conquer it, because, conquering something is not the means or not the intent for sticking with something, right? The intent for sticking with something is to be able to understand it. Because when you understand something, or when you understand someone, you appreciate them or it at a whole new level, a completely new level, right? So from knowing that person or because knowing is always from the outside. Understanding is from the inside. All right, thank you very much.
Okay, thank you very much. Okay, guys, I should go have a math class. And
right.
as Andrew said, if you need any help, just don't hesitate to contact
thank
us.
you. Thank you all. All right, I'll see you on Thursday, unless you guys, rattle my cage and say, "There's 5 of us here. Can you give us a spot lecture?" I'm happy to do that too, anytime, right? Maybe we can play it by ear. I have a lot of time right now because of this working from home thing. So feel free to reach out to me anytime, okay? I'm just, because my phone and iPad, everything is wired in. And anywhere I am, even if I'm, out there by the lake and I can get a ping on my iPad, it takes me about 10 minutes to walk back and start your class. All right. Thank you very much, guys. See you later.
Thank you. Goodbye, teacher.
Bye.
Thank you.
Bye.
Thanks, bye.